Hello guys, in this video I will talk about how you can do double and triple integrals in Mathematica. So let's look at this. So volume of hemisphere is represented by this integral. You can see that we are integrating square root of r squared minus x squared minus y squared, which is the equation of the upper hemisphere. Z equals to this, and in the xy plane y goes from negative square root of r squared minus x squared to square root of r squared minus x squared, and x goes from minus r to r. So let's do this double integral. So there are two ways to do this double integral. You can use the integrate function or you can use the integrate sign. So let's start with using the integrate function. So write integrate, and inside the square bracket let's write the expression square root of r squared minus x squared minus y squared. Normally we do this integral in polar coordinate because that's easy, but we're doing it now in Mathematica, so let Mathematica do the work. Now when you're using integrate function, you have to give the limits in reverse order from right to left. So you have to give the limit of x first, then give the limit of y. So be careful with that. So x goes from minus r to r, and y goes from negative square root of r squared minus x squared to positive square root of r squared minus x squared. Close the list and close the square bracket. So I wrote the expression inside the integrate function. Then I put the limits in reverse order. For dy dx, I put the limits of x first, then y. And now if we press shift enter, we'll get the output. It will take some time, so let's wait. So we get 2 by 3 pi r cubed, which is the volume of the hemisphere. I'll solve this triple integral using the integrate sign. You can do double integral in the similar way using the integrate sign. First do this by using the integrate function, then I will use the integrate sign. So let's write integrate, and inside the square bracket first you have to put the expression y divided by x squared plus y squared, and then I have to put the limits in reverse order. For dx dy dz, I have to put the limits of z first, then y, then x. So z goes from 1 to 2, so write z from 1 to 2, and then I have to give the limit of y, which is from z to 2, so y comma z comma 2, and then the limit of x, which is from 0 to square root of 3y. So if we press shift enter now, we'll get the output. So Mathematica is solving the integral. In the meantime, I can write my comments for the next task. So I want to integrate this using the integrate sign. So let's write the integrate sign first. So escape, DINTT, and again the escape button. Now in the middle box where we usually write the expression, write the command for getting the integral, escape button, DINTT, escape button. Okay, we have got the output for the last integral. In the similar way, I can get another integral sign in the middle. Just write escape, DINTT, escape button. So we have got the expression for triple integral. Now we just have to write the limits and expression dx dy dz, and in the middle I'll just copy paste the expression, and x goes from 0 to square root of 3y. Y goes from z to 2, and x goes from 1 to 2. So if we press shift enter now, we'll get the output. Again, it will take some time. So I've got the output, the same output. Let's solve another triple integral. Just I want to find the volume of a sphere. So equation of sphere is x squared plus y squared plus z squared equals to r squared, which is the radius squared. So let's write the integral signs. So escape di entity to get the first integral sign. Then in the similar way, we can get the second and third integral sign. So I have to integrate 1 to get the volume of sphere. Here z is plus minus square root of r squared minus y squared minus x squared. So write 1. So z goes from negative square root of r squared minus x squared minus y squared. So negative r squared, okay, to positive. Let's just copy paste this. Let's just write the expression square root of r squared minus x squared minus y squared. So on the xy plane, z is equal to 0. So y is plus minus square root of r squared minus x squared. So y goes from negative square root of r squared minus x squared to square root of r squared minus x squared. And x goes from minus r to r. And we are integrating 1 here. So let's press shift enter now. So the volume of sphere is 4 by 3 pi r cubed.